Hello, good day, good morning, good afternoon, good evening, depending on the location from which you are viewing this video from. This is Noble Mind Science Tutors Online, and this is your online physics tutorial. And for today, we'll be looking at combined capacitance. So, where we'll look at a circuit diagram where you have capacitors in series and capacitors in parallel, all combined together in one circuit diagram. We have already discussed in our previous class or lecture, we discussed arrangement of capacitors, right? Arrangement of capacitors both in parallel and in series, and we solved some problems in those in those topic. Okay, so for this particular class, we'll be looking at combined capacitance. That is what we'll be looking at today. So please get your materials, writing materials ready, your pen, your writing pad, your calculators, so that we'll go straight to the class for today. Basically, this class is going to involve calculations on capacitors in parallel and combined capacitors in parallel and in series. Okay, because we've already defined or discussed capacitors in parallel and capacitors in series. So for this particular class, we'll be looking at combined capacitance. Alright, so guys, welcome once again. This is Noble Mind Science Tutors Online, and I remain Otobo Michael. Please, if you have not subscribed to this channel, please click on the subscribe button. Also click on the notification bell so that when we upload a new video, YouTube will notify you. You can reach us through the WhatsApp number that is showing right on your screen. And our aim of putting this physics video tutorial together is to help our numerous students, because it has come to our observation as a team of science tutors that many students are afraid of physics. They have phobia for physics, and that is why we have tried to put this video tutorial together to make the subject as simple as possible. And each topic that we have treated, we make sure that we solve a lot of problems on each topic to drive home the points and explain further the principles that are guiding those topics, or the principles that are involved in solving the problems. Because once you are able to understand the principles, it's always easy for you to apply them. But if you are unable to understand the principles, then even the formula that you will be using to solve any problems, you will not be able to apply those formulas to solve. So that is what we're trying to do, to make sure that we simplify physics so that students can learn and understand the subject and then become better in it. So please, if you are not subscribed, please subscribe to the channel, click on the notification bell. Also invite your friends, give us a like, give us a thumbs up, invite your friends, help us to share this video in your various social media platforms so that other students like you will come to enjoy this particular online lecture in physics. This lecture series is tailored towards students who are preparing for different external examinations in physics. If you want to prepare for WAEC, JAM, GCE, IGCS and all that, this lecture, these videos or these lectures, they are meant for you. Right guys, so let's go straight to our class for today, combined capacitance. That's what we're treating for today. So let's move. Okay, so as I said, in this particular class, we're going to be solving just problems. Because if I say combine capacitors in series and in parallel, if I begin to tell stories about it, you will not understand anything. So the best bet I think I can explain this to you is for me to solve problems on this particular topic. So we have at least some numerous problems to solve, and I'm sure that by the time we are able to go through all these problems, you should be able to understand what it means when you say capacitors are combined together in series and in parallel. Okay, so for this particular question, say this resultant capacitance of the above arrangement is what is a jam question. Okay, so if you look at this arrangement, you will see that there are some capacitors that are in series while others are in parallel. Okay, so the 2 microfarad and 3 microfarad and 4 microfarad capacitors are in series, while these 2 microfarad and 4 microfarad capacitors, they are in parallel. So if you want to solve this problem, first of all, you will have to find the combined capacitance for these 2 capacitors that are in parallel. So once you have find the value of this, or the value for the equivalent capacitance for these 2 microfarad and 4 microfarad that are in parallel, you now combine everything together, because everything now will become in series. So you now find the capacitance in series. Okay, so what I've said is that for these 2 capacitors, the 2 microfarad and 4 microfarad capacitors, their combined capacitance is given to you. Since they are in parallel, their combined capacitance is the sum of the 2 capacitors. Okay, it is the sum of the charge of the 2 capacitors. So their resultant is equals to C is equals to 2 plus 4, because they are in parallel. Okay, so the resultant is equals to 2 plus 4, and that gives you 6 microfarad. Alright, so now we have the combined capacitance here to be 6 microfarad. So what you will now have is, you can now rearrange your drawing to look like this. Okay, so this is your 2 microfarad here. Okay, your 2 microfarad is your 3 microfarad, and then this is the equivalent capacitance for these 2 that were here before. So this is 6 microfarad, and then this is your 4 microfarad. So what you see here now is that C1, C2, C3, and C4, they are now in what? They are in series. They are now in series. So their combined capacitance is the sum of the reciprocal of the capacitance. So combined capacitance now will be equals to 1 over C1 plus 1 over C2 plus 1 all over C3 plus 1 all over C4. Okay, so just put the values of the various capacitors into that place, so that you have 1 all over 2 plus 1 all over 3 plus 1 all over 6 plus 1 all over 4. Okay, so find the LCM of all this. This should be 12, and 2 going to 12 is 6, 3 into 12 is 4, 6 into 12 is 2, and 4 into 12 is 3. So when you do this out, you are going to have that is 15 all over what? All over 12. So 1 all over C is equals to 15 all over 12, and C is equals to what? 12 all over 15. Okay, so by the time you work this out, you're going to have 0.8 microfarad. Quite simple, right? So quite simple. Okay, so that is how to solve for combined capacitance. So this is a typical combined capacitors in series and in parallel, and this is how to work through it. Okay, this is how to work through it. So we're going to solve another problem too. we'll solve another problem now too. Fine. This is another question. See, this question says calculate the equivalent capacitance and the quantity of charge flowing through the circuit above. Calculate the equivalent capacitance and the quantity of charge flowing through the circuit above. Now, you remember that when we discuss series and parallel arrangement of capacitors, for series arrangement, the quantity of charge is the same, but the PD is equal to the sum of the individual PD across each of the capacitors. Then for capacitors in parallel, the PD is the same. The quantity of charge is the sum of the individual charge in each capacitor. Okay, so in this particular arrangement, you have the 40 microfarad and the 60 microfarad in parallel. So what you do first of all is to find the combined capacitance for these two. Then you now join it with this to have a continuous continuous series arrangement first of all. Then this is the voltage that is across this arrangement. All right, so first let's find the combined capacitance for the 40 and the 60 microfarad capacitor which are in parallel. So because these two are in parallel, their combined capacitance is equal to the sum of the individual capacitor. So it will be 40 plus 60. So that gives you 100 microfarad. Okay, so this is their combined capacitance for this 40 and 60 because they are in parallel. Now your arrangement now will now look this way. Okay, so this diagram you can redraw it to look like this. Please pardon my drawing may not be too perfect, but just pardon me. Okay, so you have this arrangement now. So okay, so this is 100 microfarad and this is also 100 microfarad. Then you have the voltage across the arrangement. Alright, so now you are going to now find this combined capacitance. Okay, so the combined capacitance for this 100 microfarad and this one will be equals to, since they are in series, the combined capacitance will be equals to 1 all over 100 plus 1 all over 100. So if you find the LCM of this, this will be 1 plus 1. Okay, so this gives you 2 over 100, and then your C will be equals to 100 over 2, and that gives us 50 microfarad as a combined capacitance for this particular arrangement. Now the voltage or the PD across this arrangement is equal to V is equals to 24 volts. Okay, so now we are going to find the charge that is flowing through this arrangement. Q, charge is Q, right? So the charge that is flowing is equals to Q is equals to CV. So if you substitute to this equation, you are going to have 50 times 10 raised to power minus 6 multiplied by 24. Now, why did we multiply this by? Because quantity of charge is in coulomb. Although you can even write it in microcoulomb, but for ease of understanding, we'll write it in coulomb. And for you to convert microfarad to coulomb, you multiply it by 10 to the power minus 6. We discussed that one before. Okay, so that will have this 10. That's why we have this 10 raised to the power minus 6. All right, so by the time you multiply this out, you will have that your quantity of charge is equals to 1200 coulomb. 1200 column. That is what you will have as your answer. Is that okay? So this is how to actually go about solving some problems within this when you have combined capacitors in series and in parallel. Okay, so I hope this one is also quite simple and you understood this too. Alright, so this question number 2 that we have solved. We have other ones that we're also going to solve, so let's still go. Okay, so I hope you are learning something and you are gaining more understanding from what you are learning. Alright, so for this particular arrangement, say what is resultant capacitance of the circuit below? This is also a jam question. You know, in jam you don't need to spend more than a minute per question. Is that okay? So which means that you have to think fast. Now if you look at this arrangement, you will see that the 1 microfarad and the 5 microfarad, they are in parallel. So you first of all work with that, first of all work on that, after which you redraw the circuit diagram and then you find the resultant capacitance. So the resultant capacitance for these ones that are in parallel, C is equals to 1 plus 5 straight ties, so that gives us 6 microfarad. Okay, so having gotten your 6 microfarad, what you do next now is to redraw the circuit diagram. Okay, is for you to redraw the circuit diagram. So if you redraw the circuit diagram, you are going to have something that will look like this. So your drawing will now look this way. Okay, alright, so let's just have it like this. Okay, fine. So this is your 4 microfarad, this is 6 microfarad, and this is 4 microfarad. So you find out this arrangement now is what is in series. Okay, so their combined capacitance now will be the sum of their reciprocal. Okay, so 1 over 6 equals 1 over 4 plus 1 over 6 plus 1 over 4. Okay, so this, the LCM of this arrangement is equals to 12. So you have 4 into 12 is 3, 6 into 12 is 2, and 4 into 12 is another 3. So this gives us 8 over 12. And your C, which is the combined capacitance, will be equals to 12 over 8. So by the time you work that out, you have 1.5 microfarad as the combined capacitance. Okay, so this is another simple one. It looks simple, but this is a complete jam question. Okay, so this is another simple one, and then that is how to go about solving this type of problem. Alright, so I hope this is simple and it's not too difficult for you to understand. Let's do another one. Okay, so we have solved some problems of this. There are some other questions that are ahead of this, but before we go to those ones, I'll just introduce you to the energy stored in a capacitor. Okay, the energy that is stored in a capacitor. So that is what this we are going to discuss very briefly and very quickly on this particular aspect. Now, the energy stored in a capacitor is equivalent to the work done in charging the capacitor. So when you are charging a capacitor, the charge will build up from an initial value of 0 to a final value of Q, and also the potential difference will also build up from 0 to a final value of V. So if this potential difference builds up from 0 to V, then the average potential difference will be equals to what? This. Okay, it will be equals to 0 plus V all over 2, and that gives you half of V. And so this is half of potential difference. Now we know that work done in changing the capacitor, work done is equals to QV, Q times V. So where you have your V, you put half V there. So for energy stored in a capacitor 1, the work done is equals to half QV. So this is what I indicated as equation 1. Now we know that your C we know that C is equals to quantity of charge all over V, or that V is equals to quantity of charge all over C. Okay, so you can actually substitute this into this particular equation, and if you do that, you have that work done will be equals to half Q multiplied by QC, because if V is equals to QC, you substitute that into this one, so that work done will be equals to half Q square all over C. So that is what we have here. Is that okay? Then from Q is equals to CV, substitute that into this equation 2. You substitute that to that equation, you have that work done will be equals to half CV multiplied by V. So that gives you half CV squared. Okay, so this is the third equation for work done. So depending on the variables you are given, you can use any of these equations to solve for the energy stored in a capacitor. Okay, so these are the various equations that you can use to solve for the energy stored in a capacitor. So having known that now, we can now use this equation to solve for energy stored in a capacitor. But before then, what are some of the applications of a capacitor? 1, they are used in radio circuits for tuning. They are used in ignition systems of motor vehicles, and they are used in induction coils of some electrical devices to eliminate sparks. So if you open an electrical board, you will see capacitors all over them. Okay, so these are some of the uses of capacitors. So now let's solve some problems. A 5-volt battery is connected across the plates of a 2.0 microfarad uncharged parallel plate capacitor. The battery's charge on the capacitor after a long time is what? So what is the charge on the battery after a long time? That is what they are asking you to solve. So for this particular problem, you are given V is given to you to be 5 volts. C is given to you to be 2 microfarad. Given you to be 2 microfarad. Okay, so and we have said that for you to convert a microfarad to coulomb, you have to, to farad, you have to multiply it by 10 raised to power minus 6. Okay, it's in farad. So Q from our formula is equals to what? Q is equals to what? Is equals to CV. So, and that is what we are looking for. So substitute into this formula, C is equals to 2 times 10 raised to the power minus 6 times V, which is 5. So when you solve this out, you are going to have 10 times 10 raised to the power minus 6 column. This you can also write as 10.0 microcoulomb. Okay, so you can either write it as in coulomb or in microcoulomb, as the case may be. Okay, so this is for this particular question. That's for this question. I hope this one is simple, and this is a jam question too. Okay. Fine. This is another question that we need to look into. The diagram above shows two capacitors P and Q of capacitance 2 microfarad and 4 microfarad respectively connected to a DC source V. The ratio of the energy stored in P and Q is what? The ratio of the energy stored in P and Q is what? Now, from our initial discussion, okay, so for this particular question, let's see, you are given the capacitance of P is equals to 2 microfarad. That is Cp is equals to 2 microfarad, and Cq is equals to 4 microfarad. Okay, then you are giving V. You are giving V to be V, as PD is V and is equals to, it's given to you to be V. Alright, so you have C and then you have V. So when you now look at the equations, which of them can you apply to solve for this problem when you are talking about work done? So if you look at what you have here, you have the capacitance and then you have the potential difference. So the equation that you will use is the equation that relates capacitance to the PD. So work done or energy stored is given as half CV squared. Okay, so from the equations we derived earlier, this is the equation to use energies, because we have V and C. So energy stored is half CV squared. So now for the capacitor P, so for P we'll have half Cp times V squared. So the capacitor or the capacitance of P is equals to 2. So this one will now write it as 1 over 2 times 2 times V squared. So this cancels out, and then so which means that the energy stored in P is equals to V squared. Alright, then for Q, energy stored in Q is half Cq V squared Remember that when capacitors are in parallel, it is the same potential difference that flows through them. Okay, so this one, CQ is equals to 4. So this you can write as half multiplied by 4 times V squared. So when you divide this out, you have 2. So which means that the work done for the Q is work for Q, or energy stored for P for Q is equals to 2V squared. Alright, so they say find the ratio of the energy stored in P and Q. Okay, so you now say work energy stored in P all over energy stored in Q is equals to what? V squared all over 2V squared. This will naturally cancel out, so you have 1 over 2. So in the form of ratio, to be ratio 1 to 2. That's just your answer. Okay, so in the form of ratio, to be ratio 1 to 2. Okay, so guys, we solved some reasonable numbers of problems, and I hope that we have been able to drive home the point regarding combined capacitors in series and in parallel. So what I would encourage you to do now is go to your textbooks, solve more problems on this topic. Is that okay? Because the more problems you solve, the more you understand the topic. It's not about just teaching. Please solve problems. Okay, so I'll encourage you to solve problems. If you have any challenge, reach out to us. Okay, we are there to assist you and to help you to become better in physics. Okay, so this is your test page, and I will expect that these questions will be easy for you to solve, right? So solve them and then cross check, solve problems, and you'll become better. Okay, I don't need to say anything about these questions, just solve them, because they are simple and they are direct. So please solve them, and that's just it. All right, so thank you so much. This way we are stopping um, this class, and before I leave, please, if you are just visiting this channel, you are welcome to Noble Mind Science Tutors Online, and this is your physics video tutorial. Please subscribe to the channel, click on the notification bell so that when we upload a new video, YouTube will notify you. Alright, you can reach us through the WhatsApp number that's showing on your screen, and give us a thumbs up, give us a like, join the WhatsApp chat group so that you can tell us, we want to even know your progress as you are learning. We have gone far. We started some months back, and so far we have covered a lot of topics in physics. So if you are able to go through all the topics that we have covered so far, man, you'll be good in physics. That's okay, because I believe that we are progressing and you should be progressing with us. Alright, so please take your studies seriously, read your books, have time to study. Even while you play around, please have time to study. Okay, so that you can come out with good grades in physics. So thank you guys. We appreciate you for your time. Help us to share this video in your various social media platforms. Invite your friends, invite your colleagues, and just tell them what you are enjoying in YouTube regarding physics, so that they can also come and enjoy with you. Thank you guys, and hope to see you in our next class. Thanks.